So welcome for today's class. So now we can get started. So today we'll be doing hypothesis testing. And what's hypothesis testing? Now hypothesis testing is just the process of confirming whether the pre-existing opinion is true or false about a given subject. So that's what we call hypothesis testing. You are trying to confirm whether the pre-existing opinion or the opinion you have given, is it true or is it false? And we usually have two types of hypotheses. Number one, we have what we call the null hypothesis, and we have the alternate hypothesis. The difference is that the null hypothesis, denoted by HO, is formed to cast doubt about a pre-existing claim. That is, and it starts from a negative point with the objective of triggering more information. Let me repeat again. We are saying that null hypothesis will be formed to cast doubt. First of all, you give an opinion. Useme, Ruto will win an election. First of all, for the null hypothesis, you have to cast doubt. Hawezi. Now that hawezi is what you call the null hypothesis. First of all, you cast the doubt. And then we have said that the objective, or it starts from a negative point, with the objective of triggering more information. Wakati nimesema hawezi, then you start, when you umesema atawine, uanze kusupport your opinion. Now that's what you call the null hypothesis. Then we have the alternate hypothesis, which is denoted by HA. Now alternate hypothesis is formulated to be in agreement with the current claim. This means Ruto will win an election, and then you say, yes, of course he will win. Now that's what you call alternate hypothesis. Now, and this is formed to be an agreement with the current claim. And it's the one which will be accepted when the null hypothesis is rejected. Good. So those are the two types of hypothesis, where you have the null hypothesis and we have the alternate hypothesis. Then let's go to what we call the types of hypothesis error. Now, when we're making this hypothesis, we have two types of error we can make. One is type 1 error, and 2 is type 2 error. And for type 1 error, it's an error made when you reject a null hypothesis when the claim is true. Yeah, that's what you call type 1 error. An error made when you reject the null hypothesis and the claim is true. So that means you are rejecting a true hypothesis. Then we have type 2 error. Now, type 2 error, it's an error which is made when you accept the null hypothesis, but the claim was false. Now, this is what I mean. Here you have the null hypothesis. The null hypothesis, it can either be true or it can also be false. When it's true or when it's false, you can either accept or you can either reject. You can also accept or you can reject. Now, when the null hypothesis is true, but you decide to reject, you see you are rejecting a true hypothesis. Now, that's what we call type 1 error. Also, the null hypothesis can be false, but you decide to accept. That means you are accepting a false hypothesis. That's what we call type 2 error. So that's the difference between the two, type 1 error and type 2 error. Good. So I want us to go to another part. Now let's look at the steps in hypothesis testing. What are the steps do we follow when doing the hypothesis testing? Step number 1, you have to state the null hypothesis. After state the null hypothesis, then you also state alternate hypothesis. After you state the null hypothesis, alternate hypothesis, then you choose what we call a significance level, denoted by alpha. Yeah, that's what we call a significance level. And what's significance level? Significance level is the probability of rejecting true hypothesis. Is the probability of rejecting true hypothesis. That's what we call significance level. And then step number 4 now, you calculate the standardized Z statistic. I'll show you how to compute the Z. And lastly, you formulate decision rule. And when formulating a decision rule, this can either be one tail or a two tail test. So that's step number 5. And then lastly, it's either you accept or reject the null hypothesis. So let's go to step number 5. Tumesema, step number 5, you are formulating a decision rule. And when formulating a decision rule, it can either be one tail test or a two tail test. How do we differentiate between a one tail test and a two tail test? The difference is one. A two tail test has two tails. A one tail test has one tail. So I'm saying that let's start with the two tail test. Now, for the two tail test, it's applied when the alternate hypothesis is not equal to, uses that sign of it's not equal to. That's when you apply a two tail test. And this is how we show it. It's called symmetrical. Symmetrical inamaanisha kuna that side na kuna that side. So when your claim is in between here, you accept the null hypothesis. But if your claim is on the shaded area, you reject null hypothesis. You reject null hypothesis. And in this case, how do we get our alpha? You take alpha divided by 2. Alpha tumesema is the significance level. And significance level, if you're told that we want to be 5%, the level of significance, if you're told that alpha, it's 5%. In this case, since we're using the two tail test, you divide by 2. So itakuwa 5 divided by 2, which is 2.5%. Or if you're told significant, not significance level, if you're told that the confidence level is 95%, this is confidence level. So that means its significance level is the remaining part, which is 5%. Now this 5%, when getting the alpha here, kama hapo utakuwa unachukua alpha divided by 2, alpha divided by 2, because you are dividing by the two tail test. Then number 2, we have one tail test. Now for the one tail test, they can be 2. Number 1, when, and this one for the one tail test, we usually use it when the alternate hypothesis is either greater than or less than. That's when you use the one tail test, when it's greater than or when it's less than. So now let's start when it's greater than. When you're using a greater than, alternate hypothesis is greater than. How do we get the one tail test? And this is how we show it. When it's greater than, you show that side. So when it's on this point, you accept null hypothesis. But when it's on the shaded part, that's when you reject the null hypothesis. And in this case, you just get the alpha. If your total significance level is 5%, it will just be 5%, because you're using one tail test. When using the two tail, that's when you divide by 2. And also, when it's less than, when it's less than, in that case, how do we show that? So still this one will be a one tail test, but in this case, since it's less than, you show on the left hand side. So in this case, you are accepting null hypothesis, but it's on the other side, the shaded part, that one you reject null hypothesis. And in this case, alpha will remain to be alpha, because for all the one-tail test, if you're given significance level, you just take the way it is. So now that's the difference between a two-tail test and a one-tail test. Now for the one-tail test, there are two: when it's greater than, when it's less than. So you have to differentiate the two. So those are the steps followed in hypothesis testing. Yeah, those are the steps I was explaining. So for the tail test, I was explaining step number 5. Good. So allow me now to look at something else. I want to look at the types of distributions. And when we talk about the type of distribution, we have 3 major distribution tests. So types of distribution. Now for the distribution, number 1, we have what we call the Z-test distribution. Then number 2, we have T-test distribution. Those are the major. Then number 3, we have the chi-square distribution. And then number 4, we also have the F distribution. Now for the F distribution, we'll be looking at when we will be doing the ANOVA analysis. So the major which we'll be looking at hypothesis testing are the first two, the Z-test and the T-test. So nianze na Z-test. Z-test distribution. Now for the Z-test distribution, this one will be applied where the sample has been randomly selected and the sample size is greater than 30. So this one used when the sample size is greater than 30. And in that case, how do we get Z? Z, you take X bar minus U, you divide by the standard deviation square root of N, where what's X bar, what's U, what's that, what's N. Now, X bar is the mean for known population. Mean for known population, or is what we call population mean. Population mean. Then U, it's also mean for unknown. Mean for unknown population, or it's also what we call the sample mean. X bar mean for the known population or the population mean. U is the mean for unknown population or the sample mean. Then this one is the standard deviation. Standard deviation. N is the sample number. Sample number. Good. So that's how you get the Z. You take X bar minus U, then you divide by the standard deviation square root of N. Now this standard deviation divided by square root of N, it's also known as the standard error. This is the standard error. Standard error for the sample mean. For the sample mean. Sometimes it's denoted by SE. So that means you can also take X bar minus U divided by SE. So now SE, this one is presented by standard deviation divided by square root of N. Then number 2, we have the T-test. distribution. Now, for the t-test distribution, this one is applied where the sample has been randomly selected from an infinite population. And also, it's applied where the sample size is less than 30 items. Used when the sample size is less than 30 items. That's the major difference. Z distribution when the sample size is greater than 30, but T distribution is when the sample size is less than 30. That's just the difference. And how do we get T? T-test, the formula is the same. X bar minus U over standard deviation square root of N, like that. The formula is still the same. The only difference will be, for the Z, you use the Z table, but for T, you use the T distribution table. So now for T, when reading the Z, you'll be using the Z table. I'll show you the Z table, but for T, you'll be using the T table. But for T table, we have something we call degrees of freedom. Degrees of freedom. And how to determine the degrees of freedom? This is how we determine the degrees of freedom. In case it's a one mean, tutaona for one mean and two mean, and for two means. For one mean, degrees of freedom is equals to n minus 1. In case of two mean, it will be n1 minus 1 plus n2 minus 1. That's the only difference. For one mean, degrees of freedom, df, it's n minus 1, and degrees of freedom for the two mean is n1 minus 1 plus n2 minus 1, like that. Good. So those are the major two distribution, the Z distribution and T distribution. And we are observing here is that the two formulas are the same. The only difference is that Z will be using it when the sample size is greater than 30, and the T will be using when the sample size is less than 30 items. Another difference is that when reading the values, this one you read it from the Z distribution table, but this one you read it from the T distribution tables. Good. So let me go to another thing. So let us now we look at what we call the confidence intervals. And what are the confidence intervals? So confidence intervals, CI. What do we mean by confidence interval? Now, in layman's language, confidence interval is the probability of a parameter refers to the probability that population parameter will fall in between a certain probability distribution. Yeah, that's what we call confidence interval. Probability that a population parameter will fall in between a certain probability distribution. Therefore, the confidence interval will be used to measure the degree of uncertainty. And how do we get the confidence interval? Or before that, note that as an NB, that for confidence interval, we use a two-tail test. Kumbuka tumeona you have two types of tests. We have a one-tail test and a two-tail test. For the confidence interval, always we'll be using a two-tail test. And this is how we get confidence interval. Confidence interval, you take X bar plus or minus Z standard deviation over square root of N. Now this one use when n is greater than 30. You see, when it's greater than 30, you're using the Z distribution. Also, this is how you can get confidence interval. It's X bar plus or minus T standard deviation square root of n. We are using T when the population size is less than 90. I mean less than 30. Less than 30, like that. Yeah. And in this case, tumesema hapa use the confidence interval. That means T will be is equals to alpha over 2n minus 1. I'll show you how I mean by this. So this tumesema X bar. So what's X bar? Already we know Z. We already start deviation and this is n. So tulisema this one is the mean of known population. Then we have this Z standard deviation square root of n. Yeah, we are talking about this. So this one is also known as the margin of error. Margin of error. Where Z, you multiply by standard deviation square root of n, is also known as margin of error. Good. So with that, now we can try an illustration. Let's try an illustration on that. So you have to get the two formulas there. Yeah, let's do that illustration. We are told that we are doing question number 1. So a sample of 100 fluorescence tubes from XYZ Limited company gives a mean length of 20.5 hours with a standard deviation of 1.6. So we have n, population size is sample size is 100 with a mean length. Our X bar is 20.5 and with a standard deviation of 1.6. Required, find a 95% confidence interval and interpret the result. Find a 95% confidence interval. So how do we get that? So tumesema confidence interval is equals to X bar plus or minus. In this case, our sample size is 100. So it's 100, we are using Z times standard deviation square root of n. Already we are given X bar. So we are given X bar there. Also we are given standard deviation. Also we are given n. Remember X bar is 20.5. Standard deviation we are given as 1.6. N was 100. Now what we don't have is Z. Now how do we get Z? Z tumeambiwa hapa vizuri. Yeah. Find a 95% confidence and interpret the result. If you're told to get 95% confidence interval, that means our significance level is 5%. If confidence interval is 95%, that means this significance level will be 5%. So given our significance level is 5%. Okay, let me illustrate something here. Like that. Tumesema for confidence interval, you always use a two-tail test. Our significance level is 5%. So tulisema if you're using a two-tail test, our alpha here itakuwa 5 divided by 2. So you get 2.5%. Hata itakuwa 2.5%. Symmetrical. Half, half. Then, how do we get Z? Hii yote, if I take you back to the normal distribution, hii inakuanga 0.5 and the other one it's 0.5. If you want to get Z, now we want this probability here or the other one. the probability of this confidence interval. You see already given probability of rejecting this significance level is already 2.5%. So what you do, you take 0.5 here, the whole of this part, you eliminate this probability of rejecting a significance level 2.5. So minus 0.025. And in that, how much do you get? You get 0.475. Nirudie tena. We are saying that in this case, your normal curve is always divided into two. That's one of the assumptions. It's classified into two. We have 0.5, we have 0.5. So to get Z, or the probability, you take 0.5, you just take 1/2, minus this 0.25. You see this one, I mean this was 2.5%, because our significance level was 5%. When it's 5%, you divide by 2, half. So it's 5% divided by 2, 2.5, 2.5. So I'm taking the 1/2, 0.5, I minus this probability of the shaded part, the significance level of 2.5. So you are remaining with 0.475. So that means this region here, it's 0.475. If you want to get that specific probability, you read it from the table. When you talk about from the table, you take out your normal distribution table there. So you look for a normal curve, this one. Yeah. So we have that table. Now what we are doing, we are looking at 0.475 inside the table. So unaingia hapa. We are looking for 0.475, 0.475. We have it here. Have you seen it here? 0.475. Now you read the coordinates. This is how you read the coordinates. This is how you read the coordinates. It's 1.96. You look at 0.475, then you read the coordinates. 1.96. So kwa hivyo itakuwa 1.96. So we already now have our Z. Our Z, tumeona it's 1.96. So now we can get our confidence interval by applying this formula. It's X bar, our average was 20.5, plus or minus, a margin of error. Z, tumepata it's 1.96. You multiply by standard deviation. You already have a standard deviation as 1.6. You divide by square root of n. Our n, we are given 100. So this one will be 20.5 plus or minus. Na ukifanya hii, the margin of error, that one alone, you'll get 0.3136. So if you add, you'll get 20.8136, but if you minus 20.5 minus 0.3136, you'll get 20.1864. So your confidence interval, you should it like this. It's 20.8136, 20.1864. That's how you show your confidence interval. You're the highest and the least there. So now you can comment that we are 95% sure that the sample mean rise between 20.1864 and 20.8136. So that's how you comment. We comment that we are 95% sure that the sample mean rise between weke the lower and the upper limit there. Na hizo hizi tumepata hapa zote mbili. As simple as that. So I want us to try another question. Let's go to May 2018, question 2. May 2018, question number 2. Yeah, question 2C. Yeah, hoping we are there. So we're doing part C of the question. So you're told that Mwanaisha Ari sells tree seedling at Mavuno Market. A random sample of 9. So you see in this case, our N is 9. So it's less than 30. So in this case, we'll be using a T distribution. A random sample of 9 of the seedlings had the following centimeter and the following 18 centimeter. So you are given that. Required a 95% confidence interval of the population mean height of the seedling. 95% confidence interval. So you see our confidence interval is 95%. That means our significance level will be 5%. And we are using a two-tail test. So the first step you have to do is this. What can guide you in this case is just, so we are doing May 2018. May 2018, question 2C. The question wants confidence interval. First of all, you write the formula. It's X bar plus or minus. So in this case, we'll not be using Z. Tutakuwa tunatumia T. T, standard deviation square root of N. So what do we have? Tutafute X bar. Tutafute standard deviation. N tushapewa hiyo ni 9. And then tutafute T. How do we get that? Number one, you're not given X bar. You are not given standard deviation. But we know how to get mean. This is how you get mean. Tuanze na X bar. And then tutafute standard deviation. So here we are given the information. Has the following 18 centimeter. You just take 64 plus 62 plus 65. You add all of them. And then you divide by 9 to get X bar. So I'll be taking that, of which we have 64. I add 62 plus 65 plus 63 plus 68 plus 69 plus 65 plus 63 plus 65. And then you divide by 9. Now utapata 64.889. So already have our X bar, which is 64.889. Then tutafute standard deviation. How do we get standard deviation? This is how we get standard deviation. In absence of probability, because in this case you're not given the probability, utachukua X minus X bar squared, then uongeze zote. Then since our population is less than 30, you minus 1, and then you get the square root. That's how you get the standard deviation. Good. So we have that. Then, in this case, utakuwa unachukua, for example, the first one unachukua 64 minus, okay, instead of using all this, I want to show you how to use a calculator. Take out your calculator, show how to get all that using a calculator. Chukua your calculator. I want to show you how to use a calculator. Using a calculator to get standard deviation or to get the mean. Number one, first of all, you have to clear your calculator. Clear your calculator. And this is how you clear. Tuangalie hapa. You press shift. You press shift. And then you press mode. Mode iko hapo eh? You press mode. Press mode. Then if you press mode, utaona kuna MCL, mode na kuna all. So you press here all, number 3. You press all, you press number 3 eh? You press number 3 there. Then inauliza reset all, you just press equals eh? You press equals. Then you can press on. It's already, your calculator is already cleared. Cleared inamaanisha hapa juu eh? Imeandika only D. So that's the first step. You clear the calculator. Step number 2. How do we set? Now to set, just press mode. Just press mode. Press mode hivyo. For the other using another caliber of calculator, you can press, kama hijaleta kitu kama hii eh? If it has not come SD and regression eh? Press your mode twice. We have another type of calculator eh? Hiyo ingine you have to press mode twice eh? And then, can you see SD? SD is the standard deviation, which is number 2. You press 2. So, nirudie. You press mode, utaona SD, of which SD iko number 2. For the other caliber of calculator, you press mode twice. Kuna other calculator, you have to press mode twice. Ndio ikupe something like this. And then you press where we have SD. Now, after you have SD, which is number 2, hapo juu itakuwa imejiandika SD. Imeleta hii SD. Now, how do we use? Now, this is how we use. Unakuja hapa. You want to use. How do we indicate this data? So utakuja una press hapa. You press 64 like that. After you press 64, then you press M+. M+ iko hapa. Hapa kwa AC hapo juu kuna M+. You press 64 M+, then run to the second figure, which is 62. You press 62 like that. And then you press M+. Imeandika n is equals to 2. Unaenda to the other figure, 65, you press 65, and then you press M+. Inaleta hivyo. So ufanye hivyo mpaka mwisho. So 63 M+, 68 M+, 69 M+, 65 M+, 63 M+, 65 M+. Make sure umefanya hivyo mpaka mahali itajiandika n is equals to 9. It should be n is equals to 9. Hoping you are getting that. Now, after you're through with that, now you can press on. You can press on. So now, your information yote imeshajisave. That's why I'm pressing on. If you want to get, for example, I want us to test X bar. Unaona X bar ilikuwa 64.889. By taking the summation divided by 9, tukapata 64.889. So in case you want to get that, if you want to get mean, so tumesema you press figure, then you press M+. So now number 4. To get X bar and standard deviation. So this will get X bar and standard deviation. This is your calculator. You just press shift. I mean shift. Ukifinya shift, unaenda number 2. Shift number 2. Unaona hivyo Shift number 2. Then can you see X bar? X bar iko number 1. So finya 1 equals. You press 1 equals. And you see what I'm getting there? I'm getting 64.8888. Na ndio tulikuwa tumefanya hapa. Our X bar ilikuwa 64.889. So now nataka tujaribu X bar. X bar. So turudie tena venye tumefanya. You just press on. Nataka tuanze tena. To get standard deviation, you press again shift. Umefinya shift. Then you go back to number 2 again. Number 2. Itajiandika hivyo. So let me explain something here. Kuna hii x square root, x standard deviation of n, na kuna ingine number 3, x standard deviation n minus 1. Always be using number 3. Number 3, n minus 1, ama zingine hazina n minus 1, imeandika 2s. Always be using number 3 because number 3 is a standard deviation for small sample, less than 30. There is no way you get a figure which is less than 30. When the figure is, when n is greater than 30, that's when you use number 2. So always be using number 3 to get the standard deviation. So kama hii iko number 3, you just press 3 equals. Na utapata your standard deviation as 2.315. Yeah, so standard deviation tumepata is 2.32 or 315. Now tumebakisha t. Tulisema t, all the confidence interval will be using a two-tailed test. Na two-tailed test, this how you get t. Tulisema ni alpha over 2 n minus 1. N minus 1. This how we get it. So, like in our case, our alpha, tulikuwa tumeambiwa 95% confidence interval. So, kumaanisha our alpha it's 5%. So, utachukua 5% divided by 2, which is 2.5%. N minus 1, n is 9. However, it's 9 minus 1, you get 8. Now, if 5 divided by 2, you will get 2.5%. Let me repeat again. When using the t table, kama unatumia two-tailed test itakuwa alpha divided by 2, n minus 1. Our alpha, you see confidence interval was 95%. That means the significance level will be 5%. So it's 5, you divide by 2, then n minus 1, which is 8. And this is how you read it from the table. This is how tutakuwa tunaisoma from the table. So utakuja hapa, this is a t table. So kwa hiyo t table, remember we are using, tulisema all the confidence interval we are using two-tailed test. Unakuja hapa kumeandikwa two-tailed test. Uangalie yoyote, remember tumeona ni 2.5%. 2.5% is the same as 0. I want that 2%, ama 2.5 or 5%. Haina shida. If you either use, you see this one 0.025 or 5%, they are the same. Either using one tail or two tests, hainanga shida. Kwa t-test inakuanga the same. So utakuja hapa, where you have 0.025 or 5%, then uteremuke. Tumeona n minus 1 is 8. Paka mahali kuna 8. Hapo ndio kuna 8. 2.306. So nirudie tena. To get our t, in this case, utachukua alpha divided by 2. Our alpha is 5% divided by 2, which is 2.5 or 0.025. Or you can just use the 5% the way it is. Kwa t table hainanga shida. Then n minus 1, it's 8. So you take 2.5 paka wende mahali 8 iko. Na ndivyo nimefanya hapa. 0.025 or 5%. And then uteremke mpaka mahali 8 iko. This is 8. There. It's 2.306. This is 2.306. So that means to get our confidence interval, itakuwa x bar, of which we have the x bar, ndio hii, ilikuwa 64.889 plus or minus t, tumeona our t ndio hii hapa 2.306 times standard deviation. We already have our standard deviation here. Our standard deviation was 2.32. 2.32. You divide by square root of n. Our n was 9. So utapata our confidence interval. So how much do you get there? when you add or when you deduct. So this one will be 64.889 plus or minus. This one, if you do this one, the margin of error, you will get 1.78. So kumaanisha our confidence interval itakuwa like that. If you add 64.889 plus 1.78, you will get 66.68. If you take 64.889 minus 1.78, you will get 63.109. So that's what they wanted. So I want us to go to another part. Now that was confidence interval. I want us now, we go back to hypothesis testing. Where the hypothesis testing, that was determining the confidence interval. We go to hypothesis testing. And hypothesis testing, I want us to start with hypothesis test. Hypothesis test for one mean. Hypothesis test for one mean. Good. Now, remember we said that when doing that hypothesis testing, we have some steps we have to follow. And those are the steps in hypothesis testing. Those are the steps we are supposed to follow. When you state the null hypothesis, you state the alternate hypothesis, you have to follow those steps. Good. So now let's do an illustration there. I want us to do an illustration. Note that for hypothesis testing, you have to follow all the steps. State the null hypothesis, state the alternate hypothesis, you choose the significance level, then you calculate the standardized Z statistic, then you formulate a decision rule. Now, this one can either be one-tail test or two-tail test. And I explained how to differentiate between the two. And then you accept or reject the null hypothesis. Good. So I want us to do a question and illustration there. Yeah. So we are told that a sample of 100 fluorescence light tubes has a mean life of 20.5 hours. So that's our X bar. And a standard deviation of 1.6 and a standard deviation of 1.6. Test number A, at 1% level of significance, whether the sample comes from the population with the mean life length of 23.2 hours. What's the number one? So number one, tumepewa X bar, na tumeambiwa X bar has a mean of 20.5. Then tumepewa standard deviation, and the standard deviation is 1.6, and a sample of 100 fluorescence. So our N is 100. Tulisema when population size is greater than 30, how do we get T? I mean Z. Tulisema Z, it's X bar minus U over standard deviation square root of N. That was the formula I gave anyway, to get the Z statistic and T statistics. Now, we have to follow the steps, and this is how you follow the steps. Tulisema step number one, you determine the null hypothesis. This is how you get the null hypothesis. Utasema, mean of a known population is equals to 23.2. I'm taking you back to the question. Tumeambiwa hapa, a sample of 100 fluorescence tube light has a mean life length of 20.5. You see, this is what we call X bar, mean for the known population, because it's 20.5 when the population size is 100. And a standard deviation of 1.6 hours. A, you're supposed to get at 1% level of significance, whether the sample comes from a population with a mean life length of 23.2. You see, in this case, 20.3, haujapewa population yake. So that's what you call U, or mean for a known population. Na tunatafuta at 1% significance level. So, ndio nasema, null hypothesis utasema U is the same as 23.2. Then step number 2, you go to alternate hypothesis. You say, mean it's not equal to 23.2. Na tukasema, if when you use not equal to, you are using a two-tailed test. Then step number 3, you will determine the significance level. Na tumeambiwa 1%. Then step number 4, you take you back. Ulikuwa you calculate the Z statistics. And this you calculate the Z statistics. So tuanze hapo. How do we get Z? Z itakuwa X bar, of which we have it here, which is 20.5 minus U. So U yetu tumeona nini tumepewa hapa. 23.2 divided by standard deviation we are given as 1.6. So itachukua 1.6 divided by square root of N. Already we are given our N, it's 100. Like that. So on this one, you get negative 16.875. So now we want to determine whether to accept or reject. Tuchore hapo kaugali. So tulisema if the alternate hypothesis is not equal to, ndio tunatumianga a two-tailed test. Like that. Tukasema ikiwa hapa, you accept null hypothesis. Ikiwa huku, you reject. You reject. How do we get Z? This is how we get Z critical, yenye tutaweka huku. So in this case, we are dealing with our alpha, it's 1%. If it's 1%, tulisema hapa alpha, it's alpha divided by 2. The other side is alpha divided by 2. Kwa hivyo itakuwa, if you take, you see our alpha is 1%, 1 divided by 2. So it's 1% divided by 2, you'll get 0.5%. And then ikasema, this one is divided into 2. This is 0.5, this is 0.5, 0.5. So utachukua 0.5, which is 1/2. You minus 0, hii sasa 0.5 divided by 100, it's 0.005. Nirudie tena. You take 0. To get Z, if you want to get Z, you take 0.5, which is 1/2. You minus hii probability hii. Na tumesema hii ni alpha divided by 2, which is 1% divided by 2, which is 0.5%. If you convert 0.5% divided by 100, that's when you are getting 0.005. And this one you get 0.495. Hii unasoma inside the table. And you are reading from Z table. So how do we get that? So we need to get that one from the table. So unakuja kwa normal curve hapo, and we are looking for 0.4. We are looking for 0.49. So unakuja huku 0.495. 495. Good. Tuangalie hapa. You see there, This is 4.94849, hiyo haijafika, lakini hiyo ndio imefika 0.4951. You always take the one yenye imefika kabisa. So you can take this one or this one, but the most appropriate ni imeshapita, imepita kidogo. So after spot 0.495, you take the coordinates. Kama hapa itakuwa 2.5, then unapanda up to 8. Kwa hivyo itakuwa 1.98. Yeah, it's this one. So you take, it's 2.5. Yeah, it's 2.5 there. Then upande 8. up to that point. So our T tumeona is 2, yeah, it's 2.58. 2.58. Kumaanisha hapa, this is 2.58, this is 2.58. The only difference is that hii ni positive, hii inakuanga negative. Positive, negative. Sasa tukuje hapa. Tumeona wa Z critical here, it's 2.58. Now, if you want to determine whether to accept or reject, utakuja hapa. This was the Z calculated, 16.875 negative. Unakuja hapa. Unajiuliza, 16.87, does it fall in between the acceptance region ama iko kwa rejection region? So I need your answer there. 16.875, does it fall in between the acceptance region? You see acceptance is between negative 2.58 to positive 2.58. Should we accept or should we reject? Yeah, in this case, you reject null hypothesis, since you see already 16 point iko huku nje, since calculated Z, which is 16.875 negative, falls in rejection region. Yeah, falls between, fall or lies in rejection region. So hiyo ni ya kwanza. I want us to go to part B of the question. Part 2 ilikuwa inataka at 5% level of significance, whether the sample comes from the population with a mean life length of less than 20.8. You see? Less than. So if you're given less than, tulisema less than or greater than, that's when you use a one-tail test. Kama ya kwanza, when alternate hypothesis is not equal to, tunatumia two-tail test. Ikiwa less than or greater than, that's when you use a one-tail test. Kama hii imeambiwa at 5% level of significance, kwa hivyo alpha is 5, whether the sample comes from the population with a mean life length less than 20.8. So we follow the steps. Step number 1 tulisema is a null hypothesis. So utasema U is equal to, hapa tumeambiwa with a mean life length of 23.2. So it's 23.2. 23.2. Then unakuja kwa alternate hypothesis, unakataa that mean is less than, because tumeambiwa less than 23.2. There. Just hoping we are there. Sorry, it's 20.8. Sorry. Tunafanya part B. Yeah, whether the sample comes from population with a mean less than 20.8. So this one should be 20.8. 20.8. Sorry for that. Then step number 3, significance level tumepewa 5%. Then from there, how do we get Z? Tulisema Z ni X bar minus U standard deviation square root of N. X bar does not change. X bar from the original question ilikuwa X bar was 20.5 minus U. So in this case, our U is 20.8. You divide by standard deviation. Standard deviation does not change, ilikuwa 1.6. Is divided by standard deviation of N. Our N ilikuwa 100. Na ukifanya hivyo, you get negative 1.875. Now with this, should we accept, should we reject? Number 1, you have to get Z. Wacha nimcholee kaugali hapa. So when it's less than, hapa tumeambiwa less than, kwa hivyo itakuwa one tail test on the lower side. Una shade hiyo. Ikiwa huku, you reject. ikiwa huku you accept null hypothesis. Then tutafute z. Kama ni 5%, utachukua, tulisema hii nusu yote inakuanga 0.5 you minus our alpha it's 5%. Kama ni one tail test, you don't divide by 2. Kwa hivyo itakuwa just 2 as an alpha. Kama ingekuwa two tail test, tulisema if it's a two tail test, that's when tungechukua 5 divided by 2, 5 divided by 2. But this one, since it's a one tail test, you just take the way it is, 5%. So it's 0.5 minus 0.05 like that. Na utapata 0.45. Then you unasoma inside the table. You read it inside the table. So unakuja kwa hiyo table. We are looking at 0.45, 0.45, 0.45. I hope you are there. Here we have 0.4495 and we have 0.4505. And we are looking for 0.45. So between the two, unachukua imefika kabisa. Ona imefika 0.4505. So utachukua hiyo. And then you take the coordinates. So it will be 1.65. Good. Itakuwa 1.65. So itakuwa 1.65. And then when you're dealing with one tail test, kama ni less than, inakuanga negative. If it's greater than, it could have been positive 1.65. Let me repeat again. We are saying that if it's less than, it should be a negative. Kama ingekuwa greater than, it could have been positive 1.65. Now let's make a decision now. If you want to know when to accept, when to reject, unaangalia hii. The calculated Z. Calculated Z is negative 1.875. Unaangalia hapa. Does it fall in between acceptance or rejection? Kumbuka ukienda hivi ina increase kuwa negative, ikiwa hivi inaenda kireduce kuwa positive. So 1.875 automatically uko huku. So that means you should reject the null hypothesis. Reject null hypothesis since calculated Z ni negative 1.875 falls in rejection region. Like that. Hope you're okay up to that point. We do the last one. The last one, number 3, I mean number C. Number C ilikuwa inauliza at 1% level of significance, whether the mean life length is greater than 23.2 hours. So that one is greater than. So kama ni greater than, so tuko part C. Part C is asking about greater than. So you follow the steps. Null hypothesis, utasema U is equals to, so number C tulikuwa tumeambiwa hapa, at 1% level of significance, whether the mean life length is greater than 23.2. So U is equals to 23.2. Then you come with alternate hypothesis. Unasema U is greater than, because in this case wanasema whether the mean life length is greater than 23.2. Greater than 23.2. Then significance level, tumeambiwa at 1% significance level. Now in that case, ukichora hivyo, greater than bado itakuwa one tail test, but on the right hand side like that. So ikiwa huku you accept, ikiwa huku you reject. Tutafuta hii Z. How do we get that Z? Itakuwa very easy. You just take 0.5 minus, hii tumeambiwa alpha it's 1%. Kwa hivyo ni minus 0.01. Na utapata 0.49. You get 0.49, you read it from the table. Nisomei from the table. Now nisomei from the table and give me the answer. 0.49 from the table. as I look for Z. Z formula does not change. It's X bar minus U over standard deviation square root of N. X bar from the question was 20.5. U, sasa U tutatumia hii 23.2. Then you divide by standard deviation, of which standard deviation tulikuwa tumepewa it was 1.6. Divided by square root of N, which is 100. Napata negative 16.875. Yeah, I can see most of you are getting 2.33. Yeah, this is 2.33. Now, this 2.33, unakuja hapa kwa positive side, this is 2.33. But it's greater than. Kama ni greater than, so this one will be positive. Kama ni less than, ndio tunasema inakuwa negative. Now, I want us to make a decision. Unakuja hapa. So this is 2.33, which is greater than. Now you ask yourself, calculated Z, it's negative 16.875. So does it fall in between acceptance region or rejection region? Should we accept? Should we reject? Yeah, in this case, we should accept. On a negative 16, iko huku. Yeah, so that means comment. So accept null hypothesis. Okay, what does it mean? When we say accept, ukiaccept inamaanisha your mean for a known population is equals to 23.2. Ukireject, like for example, this one to reject. Tukireject, you see, kama ungeaccept ungesema mean is 20.8. Lakini hapa tulireject. Kama umereject, kwa hivyo inamaanisha your mean for a known population is less than 20.8. Hivyo ndivyo inamaanisha. Is less than. Kama ungeaccept is equal to. Ukireject, it's less than. So that's what it means. So andika assignment hapo. I want to give you an assignment. Assignment. So I want you to do November 2019 question 2B. Hiyo ni raw sitting. November 2019 question 2B. So I want you to do that. After I do that, the solution is already on that handout, that the one I have sent to you. So uifanye and then ujimakie. Yeah, let me give you just a small hint there. Uone haikuwa ngumu. You are told that a manufacturing company is testing a plant for acceptance. For the plant to be accepted, the mean refractometer reading should be 19.5 and above. You see, 19.5 and above. Kumaanisha ina test greater than. A random sample of 25 readings. Ukiona 25 readings, our N is 25. If N is 25, that means we will not use Z. Tutatumia T. Okay, let's do that question because naona hiyo wengi watapotea. I want us to do that question. Since our N is less than 30, tukasema when it's less than 30, that's when we apply T test. Lakini kama ingekuwa greater than 30, like the one we had already done, the previous we have done, N was 100. That's when we are using the T. So a random sample of 25 readings is taken and found to have a mean of 19.7. So in 19.7, your X bar is the mean for known population with a standard deviation of 1.5. Then test a 95% level of confidence whether the company should accept the new plant. So tumepewa hapo X bar, na tumeambiwa X bar, the mean is 19.7. And then standard deviation is 1.5. N ni 25. And then U ni 19.5 because tulikuwa tumeambiwa hapo, tuangalie hapa. For the plant to be accepted, the mean reflectometer reading should be 19.5 and above. Lakini hatujapewa population yake, that's what we call U. But hapa tumeambiwa a random sample of 25 reading is taken and found to have a mean of 19.7. Hii 19.7 ndio X bar. Lakini our U is 19.5. Tunatafuta 95%. So tukirudi hapo, tulisema step number 1 is null hypothesis. So utasema U is equals to 19.5. Alternate, U should be greater than 19.5. Alpha, tumeambiwa tutumie, you see we are told 95% level of confidence. Kumaanisha our significance level is the remaining part, which is 5%. And then ugali yako, kichora ka ugali hivyo, you are using a one-tail test since it's greater than, kwa hivyo itakuwa on that side. So tutafuta hii, so utachukua 0.5 minus, this is 5%, 0.05 na utapata 0.45. Umeona ukipata 0.45, how much do you get? If you get 0.45, hiyo 0.45 ilikuwa inatupea ngapi? Ilikuwa inatupea 1.65. If you read it from the table, you are getting 1.65. So this will be 1.65 plus, since it's on the greater side. Are you getting that? Yes or no? So, hebu tuangalie hapa. For those who are following what I'm doing, na wanaona kama wamefuata. You see, no one is asking, Robert, unasema yes, Haya, this is wrong. Nilikuwa nataka nione kama kuna mtu anafuata. Hakuna mwenye anafuata. Kwa nini? Tulisema, since n is less than 25, we will not be using the z. Tutatumia t. Namaanisha hivi, You see, hii tumeona ni 5%. So how do we get t? Tulisema, when the population size is less than 30, we don't use z test. Tutatumia t test. Na t, formula ni the same. X bar minus u, standard deviation square root of n. The formula is the same. So x bar, we have x bar which is 19.7 minus u which is 19.5 over standard deviation, tulikuwa tumepewa standard deviation as 1.5. 1.5 over square root of n. N is 25. Ukifanya hivyo, you should be getting 0.667. How do we get this t? Tulisema t, utachukua nini? It's alpha n minus 1. Kama ingekuwa two-tail test, ndio ulikuwa unachukua alpha divided by 2 n minus 1. So our alpha ni 5%. N minus 1. You see this n is 25. Kumaanisha n minus 1 will be 24. So, tuende kwa hiyo table. T table there. Unakuja kwa T table. We are looking at 5%, 24. That's the degrees of freedom, itakuwa 24. So utakuja hapa. 5% unakuja huku juu. Unaona huku kuna one tail test. One tail test unatafuta 5%, which is 0.05. Si ndio hiyo? Then uteremke mpaka mahali kuna 24. Uteremke mpaka mahali kuna 24. Unaona mahali 24 iko There is 24. 1.711. Yeah. Nimesema unakuja hapa kwa one tail test. Unatafuta 5% is the same as 0.05. Then uteremke mpaka mahali 24 iko. Which is there. 1.711. So this is 1.7. Is it 711? Like that. Na itakuwa positive. So should we accept? Should we reject? So that's the question. So in this case, we just compare this. The T calculated, which is 0.667. Does it fall in between the acceptance region ama iko kwa rejection region. So that's the decision you just need to make. Should we accept? Should we reject? So in that case, we should you should accept. You see 0.66 iko huku ndani, so you accept. When you accept inamaanisha aje? If you accept null hypothesis, that means the mean for a known population is equals to 19.5. Good. Na hii imeisha hivyo. I want us to try another question. Go to this question. May 2017. May 2017, question 3A. May 2017, question 3A. Hoping we are there. Question 3 umeambiwa, mwangaza limited is in the production of electric bulbs. A random sample of 10 electric bulb. You see in this case, our N is less than that. Kwa hivyo tutatumia a t-test. A random sample of 10 electric bulb produced by the company yielded the following results on the lifetime of the bulbs. So umepewa hizo zote. The hypothetical population mean of the lifetime of the electric bulb is given as 4,000 hours. Now the question is, this mean, is it X bar or is it U? Okay, in short, is it mean for known or unknown? You have to ask yourself like that, that question. Is 4,000, tumesema X bar is the mean of known population. U is the mean of unknown population. Let's try to think that. Is the 4,000, you see we're told that hypothetical population mean of the lifetime of the electric bulb is given as 4,000 hours. Is it known, mean of known or unknown? I just want you to write either known or unknown. Is it known? Is it unknown? So you need to think on that. So if you don't give you an answer, I just continue. So the question is, required, test a 5% level of significance whether there is a significance difference between the sample mean and the population mean. Sample mean and population mean. So in this case, steps, utakuja hapo utasema U is equals to 4,000. U is not equal to 4,000. You see, in this case, we're not told, is it greater than or is it equal? Is it not greater than or less than? Kama hawajasema greater than or less than, unasema it's not equal to that. And then, alpha, tumeambiwa at 5%, at 5% level of significance. Then how do we get T? Because in this case, our N is less than 30, so you'll have to use T-test. Tumesema ni X bar minus U, standard deviation square root of N. Hatuna X bar, but we have U. We don't have standard deviation, but we have N. So with this information given there, with that information, first of all, tutafute X bar na tutafute standard deviation. I showed you how to use a calculator. I want us to use a calculator. Tulisema step number 1, you clear your calculator. And how do you clear? You press shift, you press mode, utaona hizo zote. You want to clear everything, all 3 unafinya equals, and then you can press on. I want to use a calculator. Then to set the formula, you just press mode. Unafinya tu mode. Sinaona mali kuna SD, that is standard deviation. Unafinya hiyo number 2. You press number 2. Na imekuletea kitu hapo SD. Ukishafanya hivyo, how do we insert the formula, the figures? So unachukua kama hii ya kwanza, which is 4400. So 4400, then unafinya M plus hapa, M plus, M plus, unachukua hiyo ingine, which is 4800, M plus, that 700, M plus, 39, M plus, 55, M plus, 4000, M plus, 37, M plus, 41, M plus, 4000, M plus, 54, M plus. Until upaka uone n is equals to 10. Ukiona n is equals to 10, now you can press on. Finya tu on. So now we want to get x bar. To get x bar and standard deviation, tulisema unafinya shift, you press shift, then you go to number 2, you press 2. Itakuletea kitu kama hiyo. X bar iko not number 1. Iko number 1, you can see it, X bar there. So kama iko number 1, you just press 1 equals. So unakuja unafinya 1 equals na itakuwa imekupea hapo. Our x bar is 4350. 4350. So x bar it's 4350. Now tutafute standard deviation. Rudia tena. The way you have done, I want you to do the same. The way you have done. Finya 2 on kwanza, Finya 2 on. It's like that, Nimesema you press shift, then you go to number 2. You press 2, Utaona kitu kama hiyo. Tukasema for the standard deviation, unachukua hiyo iko number 3, not number 2, Chukua hiyo iko number 3. Tulisema that's the standard deviation for small samples, Nafinya 3 equals. 3 equals. Yeah, I mean, yeah, 3 equals, Na utapata 665.415. That's the standard deviation. So you are getting 665. Can call it 42, So itakuwa x bar, we already have it here, it's 4350 minus u, our u hapa tulikuwa tumepata, our u was 4000, Our u was 4000. You divide by standard deviation. We already have our standard deviation as 665.42. You divide by square root of n. And yet we require 25. Was it? No, sorry, it was 10, sorry. Our n was 10. So ukifanya like that, you should get 1.663. Now ukishapata hiyo, so now you have to make a decision. Should you accept, should you reject? Tukuja hapa kwa ugali like that. When it's our alternate hypothesis not equal to, tunatumia a two-tail test. Na sisi tunatumia 5%, hii itakuwa 1.96, 1.96. This is positive, this is negative. When you're shida mahali imetoka, this is how we get that. Sorry. Now this we are using t, sorry. We are using t, not z. So ignore that. Just ignore that. We are using t-test. Now t-test, tulisema this is how you get t. It's alpha over 2 when you are using a two-tail test. Then n minus 1. Our alpha was 5%. Kwa hivyo itakuwa 5 divided by 2, which is 2.5. Then n minus 1. Our n ilikuwa 10. So kwa hivyo itakuwa 10 minus 1, which is 9. So to get that, unaenda kwa hiyo table hapo. Hoping we are there. Yeah, you go to the t table there. That's t table. since you are using unakuja hapa, you are looking at, you see tumeona it's 5 divided by 2 which is 2.5%, or tulisema kwa tia hainanga shida, either it's one test or two tests, eh? You can either take 5% or 2.5%, eh? Unakuja huku juu, kuja huku juu, we are looking at two-tail test, eh? Ndio hiyo, unaona 5% or 2.5%, they are the same, eh? Then uteremke mpaka mahali kuna tumeona n-1 is 10 minus 1 is 9. Kuja mpaka hapo 9 is 2.262. 2.262. So it was like that, eh? So this one will be 2.262, 2.262, a positive, a negative. Then you ask yourself, our calculated T was 1.633, 1.663. Na hii tumeona is 2.26. Should we accept, should we reject, eh? Yeah, 1.66 iko ndani. You see it's positive, so it's almost here, it's here, approximately there. So that one we should accept. Accept the null hypothesis. Yeah, the null hypothesis inamaanisha that the mean of a known population is equal to 4,000. So inamaanisha hivyo. So now let's do another part. Let's go to another part. So let's go to the whiteboard. So now we want us to look hypothesis testing for two means. Eh? We do hypothesis test for two mean or two samples. Eh? So now when you talk about two samples, how do we get that? The steps are still the same. What changes is just the formula. So in this case, when you're talking about two mean, this is how we get Z or T, the formula. In case we have two mean, utakuwa unachukua X bar 1 minus X bar of 2, you divide by standard deviation of sample 1 squared, you divide by N1, plus standard deviation of 2 square, you divide by N2, then all of it, you get the square root. Either when you're using Z or when you're using T, the formula is the same. Now what changes is only the table will change, eh? The table to read from. So fungua hii swali. December 2017, question 2B. December 2017. December 2017, question 2B. Yeah. Hapo umeambiwa, a company produces two types of electric component whose information has been provided to you as follows. So you have component X, component Y. Mean life in hours, hiyo ni X bar. Standard deviation umepewa, sample size. You see the sample size, eh? Sample size itakuguide whether to use T, when to use Z. So in this case, they are greater than that. So tutatumia Z test. Eh? Determine whether the quantity the quality of the two type of electric component differs significantly. Use a significance level of 95%. So in that case, steps ni zile zile. Ustaz null hypothesis. Now for the two samples, unasemanga that mean for sample 1 is the same as mean for sample 2. Then when the alternate hypothesis. Mean of 1 is not equal to mean of 2. Significance level, tumeambiwa 95%, kumaanisha this is the same as 5%. Then tuende kwa z, because tumeona n is greater than 30, so that means our z, the formula is the same. Utachukua hii, tumesema ni x bar 1 minus x bar 2 over standard deviation of 1 squared over n1 plus standard deviation of 2 squared over n2, then you get the square root. Tuanza na hizo ma x bar. X bar mean life length, hii ni 16, hii ni 15, 28. Standard deviation is 132, 149. Sample size is 120 and 110. So here, x bar 1, tumepewa 1600 minus x bar 2, which is 1528. You divide by standard deviation of 1 in 132 squared to get the variance. You divide by n1. Sample size of component x ilikuwa 120 plus standard deviation of 2 squared. Standard deviation here is 149 squared, n yake ilikuwa 110, and then you get the square root. If you do like that, you get 3.865. Then to determine whether to accept or reject, since this one is not equal to, kwa hivyo tunatumia a two-tailed test. Ikiwa hapa una accept, you accept null. So utapata 1.96, 1.96. And how do you get 1.96? You just take 0.5 minus, when using two-tailed test, itakuwa alpha divided by 2. Kumaanisha our alpha is 5%. So this one will be 2.5, 2.5. So utachukua 0.5 minus 0.025. Na utapata 0.475. If you read this one from the table, you will get 1.96 plus minus. Now the question is, should we accept, should we reject? Sasa unaangalia hii 3.865, does it fall in between the acceptance region or iko kwa rejection region? Then unaandika your comment. Hiyo ni kazi ya macho kuangalia tu. And 3.865 iko huku kwa rejection region. So that one we need to reject. Yeah, you reject null hypothesis. Ukireject na maanisha mean of 1 is not equal to mean of 2, of which ni ukweli. That's the truth. If you reject, mean of 1 is not equal to mean of 2. Now, if you confirm this, tuangalie hapa. Component x ni 1600, na hii ni 1528. You see they are not the same. Yeah, that's what you are testing. So assignment, I want you to go and try this question. May 2018, question 3B. May 2018, question 3B. Actually, you can do question 3A and B. A and B, question 3A and B. That's May 2018. And here is the question. Now that question, tulikuwa tumefanya hii question ya kwanza. Part C tulikuwa tumefanya question 2C, ile ya Mwanaisha Ali for the confidence interval. Then the same exam, the same paper question number 3 wakauliza, explain the difference between the following set of terms as used in hypothesis testing and estimation. Number 1, type 1 error, type 2 error. Wenye walikuwa nikianza introduction, I explained that. What's the difference between type 1 error, type 2 error? Also, the difference between one-tailed test and two-tailed test. You get another 4 marks. Then part 2, Faida Limited is in the manufacture and sales of product named Big. The company sells the product into 2 of its distribution outlets, A and B. The data below relate to a random survey of monthly mean sales of the product of the 2 outlets. So my outlet A na B, monthly mean sales, hiyo ni X bar, standard deviation na sample size. You see the sample size will determine whether to use the T or Z. So in this case, since they are more than 30, utatumia bado Z. So in the same the one we have done. Test at a 5% level of significance. Hiyo utafanya. So now let's do the last question. We do the last question. then we call it a day. So let's do try this question. November 2018, question 1C. November 2018, question 1C. So you see, hypothesis testing never misses. So kama hujashika, you better cram it. Hiyo ni kama hujashika. So we are doing November 2018. Are we there? Yeah, November 2018, question 1C. And we are told that so a company operates under two departments, P and Q. Details relating to a sample of employees working in the two departments have been provided as follows. Tumepewa number of employees, 29, 24. You see, in this case, number of employees will be our N. And our N, you can see we have 29 and 24, which is less than 30. So do we use T or do we use Z? T or Z? First of all, you have to think that. Do you use T? Do you use Z? So in this case, we'll be using T test. Then average monthly salary. Average monthly salary, hiyo ni X bar, that's the mean. And then you are given the standard deviation. Required. Determine whether there is any significant difference between the average monthly salaries of employee working in the two departments. Use a significance level of 5%. So what you note, we have two departments here. So still this one we are using for two mean na tumesema. So utakuja null hypothesis, alternate hypothesis, na the significance level. Utasema mean of department 1 itakuwa mean of department 2. Then ukatae mean of 1 is not equal to mean of department 2. Significance level tumeambiwa at 5%. Then tunatumia T. When you are getting for two tail test, for two means, tumesema ni X bar 1 minus X bar 2 divided by standard deviation of 1 square over N1 plus standard deviation of 2 square over N2, then you get the square root. You're given there. Number of employee hiyo ni N. Average monthly salary umepewa hiyo ndio X bar 260, 310. Standard deviation 25,000 and 30,000. So itakuwa hivi 260,000 you minus 310 you divide by standard deviation of 1 ilikuwa 25,000, then you square over N. Number of employee walikuwa 29 plus standard deviation of 2 which is 30,000 you square over N yake ilikuwa 24, then you get the square root. With that you get negative 6.5. Whether to accept or reject, unachora kaugali hapo, and this one is a two-tail test. Hii una accept. Since we are using 5%, okay, kwa exam ukiwa na 5%, but sorry, this one is not a Z test. Hii ni T test. Now, kwa T test tunatumia T. Na tulisema, how do we get degrees of freedom if we have two means? It's N1 minus 1 plus N2 minus 1. So N1, you see, ilikuwa 29, so it's 29 minus 1 plus N2 ilikuwa 24 minus 1. So this is when you have two samples. Tulisema kama ni sample moja, if it's just one sample, tuangalie hapa, it's for one sample tulisema, unachukua T, it's just, unachukua alpha, alpha divided by 2, N minus 1. Lakini kama ziko mbili, utakuwa 2, alpha divided by 2, but sasa hii, the degrees of freedom, that's when you are taking N1 minus 1, N2 minus 2. And this is 28 plus 23. Hii utapata 51. Na hapa, tunaangalia our alpha tulikuwa tumeambiwa ni 5%. So you can either use 5% or 2.5%. You divide by 2. Tulisema when you use the T test, hainanga shida, it will give you almost the same answer. So tunaangalia hii 5% or 2.5, twende mpaka mahali 51 iko. So utakuja hapo. There, ukuja huku juu. You're looking at 5%, ndio hii 0.05 or 0.025. Then uteremke up to where we have 51. Now what you'll note is that we have 30, 40, 60. So 51 is not there. When a figure is not there, unatumia ile iko karibu. So what do I mean? We have 40 and we have 60. And 51 is in between the two. So unaangalia 51 imekaribia 60 ama imekaribia 40. Now 51 is more closer to 60 than to 40. So unaangalia 60. So utakuja hapo, ya 60 ukuje mpaka hapo. And you have 2.000. So this is 2, this is 2.0, 0. This is minus, this is positive. And then unaangalia 6.5 here. Unajiuliza is 6.5 negative. Does it fall in between acceptance or rejection region? Negative 6.5 automatically uko huku. So that means you should reject the null hypothesis. You reject the null hypothesis. Ukireject inamaanisha aje? If you reject, hii ni kama ukiaccept. If you reject null hypothesis, that means you accept the alternate hypothesis. Na kumaanisha kama umereject, umechukua hii, where mean of 1 is not equal to mean of 2. So far so good. So you'll go through those. From the handout that I had sent last class, I have done more illustrations. So ufanye zenye tumefanya plus those other illustrations there. The solution is already provided. So in case you have a burning question, you can raise your hand. I give you an opportunity. Kama hauna, you allow me now to go home. Any burning question? You don't text there. You just ask a direct question. You just raise your hand. Good. Hakuna. So enjoy your evening. Good.